Hi everyone, hope all of you are having a great time. Yeah, so welcome back to the channel, and today we are going to discuss another interesting question of linked list. The problem statement says that you have been given a linked list and it consists of n nodes, right? And probably some of the nodes are duplicates, right? So you have to remove duplicate nodes from a linked list. And the interesting part about the question is the linked list is sorted. So the problem statement is finally that you have to remove duplicates from a sorted linked list of size n, right? So we'll discuss the algorithm approach as well as the code of the question. So let's get started. So let's discuss the algorithm of the problem. Now let's suppose you have been given a linked list 1, 2, 2, 3, 4, 5. And since 5 is the last node of the linked list, so definitely it will be pointing towards null. Now as you all can see, this is a repeated node 2, right? So we want to delete at least 1 2, either this 2 or this 2, and the final linked list should look like 1 2 3 4 5, right? Because we are deleting the duplicate nodes in a linked list and we want only to print the distinct nodes in a linked list, right? So how can we do that? Now see, here's the approach to it. What we'll do, we'll run a loop, right? And till what should be the condition in the loop? The next of current should not be equal to null. That is, we will take a current pointer and we will initialize the current pointer to the head of the linked list. This is the head of the linked list because it's the starting node. So the current pointer will be initialized by head of the linked list. Now we are going to check if the data of the current pointer and the data of the next of current pointer, so are these two equal? Now since they are unequal in this case, so what we will do, we will just update the current pointer. So current pointer will move one step forward, right? So now this is not the position of current pointer, the current pointer is pointing to this node 2, right? Now again we'll check the same condition. We'll compare the data of the current pointer and the data of the next of the current pointer, right? And we'll check if these two datas are equal. Now here in this case, these two datas are equal because the data of current is 2 and the data of the next of current is also 2. So what we will do here is we will change this link, right? So how will we update this link? We'll update the current dot next becomes equal to current dot next dot next. That is, the next of current gets updated to the next of current. So this was actually the link where the next of current was pointing to. This was current and this was the next of current. So this link gets destroyed, this link gets destroyed, this node gets destroyed, and finally this is a new link created, right? So now this is current and this is the next of current. All right, so now we are going to check the same condition once again. If the data of the current pointer, this is the current pointer, and the data of the next of the current pointer, this is the next of current pointer, right? So if these two data are equal or not, now definitely they are unequal because they have distinct data. So what we will do in this case, we are just going to update the value of the current pointer. We'll move it one step forward. So this gets deleted and it moves one step forward. That is, current pointer gets updated to the next of current pointer. So now current finally points to node 3, right? Now repeating the same procedure once again, we'll check if the data of the current pointer and the data of the next of current pointer are equal. They are unequal, so we'll just update the value of current pointer, right? Now we'll again check if the value of the current pointer and the value of the next of current pointer, are they equal or not? So they are not equal, so we'll just going to update the value of current pointer. Now when the current pointer reaches here at node 5, just remember the condition we included in our while loop. The condition was that we have to run this loop till the next of current does not become equal to null, right? Current next does not become equal to null. but here in this case this is current and this is the next of current, which is equal to null. So the loop gets terminated and we are ready with our answer. So we all can see that 1, 2, 3, 4, 5 is an updated linked list in this case, because this 2 has been automatically deleted, right? Now let's take another example to understand the same concept. Suppose this is our linked list, 2, 2, 2, 2 and finally a 3, right? So these are duplicate values and the final answer which we wish to obtain, it should be 2 to 3, right? This should be our final linked list. So we have to actually delete 3 2's, right, because they are duplicate values. So what we'll do, this is the head of linked list, so we'll initialize the current pointer to the head. Now and yeah, this is pointing to null. So we'll check the date of current and the date of next of current, are they equal or not? They are equal. So what we'll do, we'll just update this link. So we'll update next of current becomes equal to next of current, right? So this node gets deleted because these two links get deleted. Now current pointer still remains at this node, right? So we'll make a comparison. The date of current, is it equal to the data of the next of current? Now this is the next of current in this case, and we again notice that these two datas are equal. So we'll update this link once again. So the next of current becomes equal to next of current, right? And this previous link gets deleted and this node and these links get deleted, right? Now current still stays at this position and this is the next of current, right? So we'll again make a comparison. If the data of current and the data of the next of current, are they equal or not? They are again equal in this case. So we'll have to update the pointer once again. So next of current becomes equal to next of current, right? And this previous link again gets deleted, this node gets deleted, this link gets deleted, right? Let me just make it a little clear. Yeah, now current pointer is still pointing to this node 2 and this is the value of the next of current pointer 3, right? Now we'll again draw a comparison. If the data of current and the data of next of current, are they equal or not? So in this case they are not equal, so we have distinct nodes, right? So now what we'll do, we'll update the value of current pointer to the current pointer becomes equal to the next of current pointer, right? So basically what are we doing in these type of questions is, if the data of current pointer and the data of the next of current pointer, if they match, so we are just going to update the next of current to the next of current, right? And if the data of current pointer and the value of next of current pointer do not match, it means they are distinct nodes. So we just need to update the value of current pointer. We need to move it one place forward. So current node becomes equal to the next of current pointer, right? So this is the basic algorithm being followed in the problem. So now let's come to the coding part. So let's discuss the code of the problem now. Now since it is a question of a linked list, so definitely we have to create a node, right? So first and foremost task is to creating a structure of a node, and a node comprises of a data and a next pointer in a singly linked list. We all know that. Now we also have to initialize our values. So let's initialize data with D and next pointer with null, right? So we are done here, and this much part, that is creating a structure of a node, right? So this much is pretty much the same for every question of linked list, right? Now comes the actual function. So let's define a class calc and let's make a function, and the return type of the function has to be node type, right? Because we are going to return a linked list without any duplicate nodes, right? A distinct node linked list in the end, but it is also a linked list, right? So we are going to actually return a head, and head is actually a node type, so definitely the return type of this function has to be node. All right, Now let's give this function a meaning, some name. So I'm giving it x, and it has to accept a head node, the node of the head node of whatever linked list we are given, right? The linked list which consists of duplicates. And yes, remember that in this question we are solving it for sorted linked list, right? So now what we'll do, as described in the algorithm, we'll create a current pointer and we will initialize it to the head of linked list, right? We already saw it in the algorithm. Now we will include a loop, and till what point the loop will run? Till the next of current does not become equal to null, right? So as soon as the next of current becomes equal to null, the loop will get terminated. Or in other words, as soon as our current pointer reaches the last node of the linked list, so after that point the loop will get terminated, right? So now what we'll do, we are just going to check if the data of current node is equal to the data of the next of current node, right? If this condition is true, that is the data of current node is equal to the data of the next of current node, it means we have duplicate nodes. So we are going to update our next pointer, that is the next of current become equal to the next of current. We already saw this in the algorithm, right? So if this was 2, this was 2, this was 3, and current was pointing here, so the data of current and the data of the next of current were equal. So we updated these links because the next of current became equal to the next of current, right? So this node got deleted, and finally we had 2 and a 3 left. So this was all about this particular line. And now if this condition, this if condition gets false, so else, it means the data of the current node and the data of next of current node are not equal. So in this case we are just going to update the current pointer and we are going to set it to the next of current pointer, right? Basically if this is 1, this is 2, so current is here, so the data of current and the data of the next of current are not equal. So what are we gonna do? We're just going to update the current pointer to the next of current pointer. So this is the new position of current pointer now, and this position has gone, it has vanished, right? So this is what this particular line is doing. Here our while loop has finished, and since the while loop has finished, so all the duplicate nodes have already been deleted, right? So in the end we are just going to return the head of the linked list, and whatever head we are going to obtain in the end, so by just doing next of current nodes, we can traverse the entire linked list, and this final linked list which we will obtain, it will not contain any duplicate nodes, right? So now let's discuss the time and space complexities of this problem. See, time complexity, what can be the worst case possible, that we have to travel all the n nodes, right? If there are n nodes in a linked list. So if there are n nodes in a linked list, so the time taken will be order of n, because we will have to traverse all the n nodes in a linked list, right, to obtain the final answer. And what's the space complexity of the problem? So space complexity is just a constant factor, that's order of 1, because we have not used any extra space apart from what's really needed. We have not created any new array, any new stack, any new queue which could have used some space, right? So since we have not used any extra space, so space is of the order of 1 and time is order of n, where n is the number of nodes in linked list, right? So guys, this was all about the concept of removing duplicates from a sorted linked list consisting of n nodes, right? We discussed the algorithm, code, time and space complexities. So I hope all of you might have understood the logic by now, and we'll come up with similar questions very soon. So stay connected, Happy coding. Take care.